Hello viewers, I am Kausalya. Today we are going to see the steps involved to solve a problem using Nyquist criteria. The first step is we have to count the number of poles and zeros that lie on the right half of the S-plane. Right. So how to find the poles and zeros? It depends upon the problem given. Right. Only if we know the problem we can do this step. Then the next thing is we have to find the number of encirclements. So number of encirclements is given by the formula n equal to p minus z. P is nothing but poles that lie on the right half of z plane and z is nothing but zeros that lie on the right half of z plane. Right. So using this formula, we have to find out how the number of encirclements around the point this minus 1 plus 0j or simply minus 1. Right. Then the next step is we have to select the Nyquist path as per the function. That is, depending upon the problem, we have to select the Nyquist path. This is our given problem. Right. So when you look here, there are no zeros, but we are having 3 poles, right? Here one pole is lying at origin. Do you accept? Because here we are having an individual S term, so that is a pole at origin. So pole at origin, it will lie exactly at this point, right? So this is your S-plane, and S-plane has real and imaginary axis, as we all know. So real axis is denoted by sigma and imaginary axis by j omega, right? You see here j omega. Now, since we are having a pole at origin, here I have bypassed that pole. See, suppose in the given problem, if there is no individual S term, if this S is not present, then no need to bypass this origin. We can draw a straight line that passes through origin, right? And the thing is, we have to divide this diagram into different sections. So here you see, this is your section 1. That is, it starts from here to here. And this is your section 2. It starts here and it ends here. And this is your section 3. It starts here and ends here. And finally, this part is your section 4. It starts here and it ends here. Right. So, this is our third step. Here we have to set the limits also. So this is your positive imaginary axis, right? So the maximum value is infinity and the minimum value is 0, right? So since this is a positive axis, here I am mentioning it as plus j0. And similarly, when you consider your third part, it starts at, you see, since this is our negative imaginary axis, here the 0 is represented as minus j0 and here the maximum value is minus j infinity. And as we all know, the radius of the path is always infinity. We have seen this in our introduction part, right? So here comes the end of our third step. So our fourth part is analyzing the sections as starting point and terminating point, right? Just now I explained for each and every section there will be a starting point and ending point. And analysis of the last section is not required. This we can see while solving a particular problem, right? Then the fifth step is mathematically find out omega PC and intersection of Nyquist plot with negative real axis by rationalizing g of j omega h of j omega. So here what we are going to do is we are given with a problem, right? So for that problem we have to find the values of, that is, expressions of magnitude and phase angle. Right. Once the values of magnitude and phase angle are given or find out, then it is very easy for us to find out this omega PC. Once omega PC is find out, then it is easy for us to find the intersection point on the negative real axis. Right. So this I will explain you with a diagram. So this is a perfect Nyquist plot. Right. So here this is drawn on the f of s plane, right? First, we have to mark the angles here. So this is 0 degree. When you move anti-clockwise, you should have only positive angles. So here plus 90 degree, plus 180 degree, and here when you move down, you will be having plus 270 degree, right? Suppose if you move clockwise, then you will be having negative angles. So here the negative angles are, you see it starts from 0. So here minus 90, minus 180, and here it is minus 270, right? So just now we seen that we have to find the intersection point of Nyquist plot with the negative real axis. So this is your real axis and this is your positive side and this is your negative side. You see here there is an intersection point, right? So we have to find this intersection point, right? This can be solved only if you know the problem exactly. Just to show you what is an intersection point, I have taken this, right? So in the fourth step, you see we had find out the starting point and terminating point of each section, right? And in the fifth point, we had find out the value of omega PC and the intersection point with the negative real axis, right? So since we have find out these two things, by using these two values, we have to sketch the Nyquist plot, right? So after sketching the Nyquist plot, the last thing is, you see, we have to count the number of encirclements n of the point minus 1 plus 0j. That is, you see, here there is an encirclement, right? If the point lies inside this path, okay, if the point lies in this path, then that point is said to be encircled, right? But here, what is the thing? We have to check whether the point minus 1 plus 0j got encircled, right? But how we can know whether minus 1 lies here or whether it is lying outside? How we can find out? Only if we know the value of this q, we can easily tell whether the point minus 1 lies inside or outside. That is, in other words, whether the point this minus 1 plus 0j is encircled or not encircled, right? So the main thing is, for example, suppose assume let the value of q be minus 2, right? Suppose if the value of q is minus 2, now tell me whether this point is encircled or not. This is minus 2, right? So automatically minus 1 have to lie in this area because this is your origin, this is your 0, right? So in this case, we can say that the point minus 1 plus 0j is encircled, right? For example, if you have the value of q as some 0.7, right? If the value of q is here minus 0.7, then what about this point minus 1 plus 0j? Whether it lies inside this area or it will be lying outside, because this is 0.7. So automatically here minus 1 lies outside. So here this point is not encircled if the value of q is minus 0.7, right? So now we have checked whether the point minus 1 plus 0j is encircled or not, right? Then if this n matches with the step 2, what is our step 2? In step 2 is nothing but we had find out the number of encirclements, right? That is n is equal to p minus z. Using this formula, we had calculated the value of n, and that n should match with this n which is drawn in the Nyquist plot, right? So again consider the diagram. Here, for example, let us assume the value of n is 0 for a problem, for this problem. So when the value of n equal to 0, what it means? This diagram should not encircle this point minus 1, right? Am I making the concept clear? If you are having n equal to 0, what it means? This minus 1 point should not get encircled, right? Then tell me which case will suit here, whether minus 2 or minus 0.7 will suit this. Here minus 0.7, if the value of q is equal to minus 0.7, then the point minus 1 will be somewhere lying outside here, right? So in this case, the point minus 1 is not encircled and here the value of n is 0. So here both the conditions are met, right? We need the value of n equal to 0, and by even after drawing the plot, here also we are getting the number of encirclement around minus 1 is 0 because minus 1 lies outside here. Right. So if these two conditions meet, then the system is said to be stable, or else the system is unstable. You will get a clear idea after solving some problems. Here comes the end of this video. Hope you people understand. If you have any doubt, let me know in the comment section. Thank you.